This is a short update on my groundwater cooling project. Over the last weeks I made one small change that has surprisingly big impact on the system. It drastically reduced the amount of groundwater that I use, while give me much more control over the cooling. For the last few weeks I've been running the pump with a manual controlled PWM controller, and a few days ago I received this BTS motor driver. For those of you into electronics, this might be completely basic stuff, but I never used a component like this before. So I found it really cool to get it working in a test setup in my workshop. And now I will install it in the cooling system. So this is what I'm going to use from now in my real world setup. And I also wanted to show one really simple automation that I made for refilling the buffer tank. It's now much more fault proof. And finally we have a quick look at some of the data that I've gathered over the last weeks. So let's go. So this is the BTS PWM controller that I'm using. And previously I had a 12-volt power supply running next to the buffer tanks and the groundwater pump. But in this new setup I decided to run the 12-volt wiring from the attic. I already have an ESP32 running there for all the sensors. And now this allows me to install the BTS controller directly next to the ESP. From there, two wires run outside for the supply of the groundwater pump. By using this PWM controller, I can now control the flow of the pump from about 100 liters per hour all the way up to about 400 liters per hour. And being able to control that automatically is really useful, because it gives me a lot more options of automating the entire cooling system over time. And there is one little side story that I want to tell you. We are in my quite messy office, but here is the place that I can show you exactly how it works. This is some pretty typical way of how I often solve things. Sometimes I end up with a rotary knob that I want to automate, but I don't know how to control it directly with an ESP. So I just hack my way around. I design some parts, 3D print them, connect a servo to it and let the servo physically turn the knob. And hey, it works awesome. But you can probably imagine that it feels slight over-engineering when an off-the-shelf solution like the BTS controller exists for the current project. So I'm pretty glad that I found this instead of hacking my way around the rotary knob for the manual PWM controller. But I thought this was fun to show you as well. The second improvement isn't complicated at all, but it made my life a lot easier. Previously I simply ran the groundwater pump for about 4 minutes to fill the buffer, stopped it and then started a 30-minute timer before filling it again. And that worked, but there was always a small mismatch. The buffer would slowly get fuller or slowly drain, until eventually the small circulation pump would run dry. That's not really a problem for this pump, but obviously it's not a very efficient way to run the system. At first I thought about adding another water level sensor to the buffer, but then I realized that I'm already measuring something that tells me exactly when the buffer is empty, the flow. So instead of adding another sensor, I simply use the flow measurement I already have. If the flow of the small circulation pump drops below 70 liters an hour, the automation waits 30 seconds. If it's still below 70 liters per hour, after those 30 seconds, it runs the groundwater pump for 3 minutes to fill the buffer. The flow then automatically returns to its configured level and the system continues running. And that's basically a continuous little feedback loop, making sure there's always enough cooling water available. And although this sounds pretty straightforward, I think it's actually quite a neat solution. It prevents me from adding another sensor, more wiring and another possible point of failure. So it perfectly supports my mission of keeping things as simple as possible. Although looking at all the sensors, wires and automation this project has collected by now, you might be allowed to laugh a little bit about that statement. The third thing that I want to look at quickly is some of the data that I've gathered. There have been quite some changes to the system over the last few weeks, and it hasn't been running much as before, simply because the temperatures outside were pretty comfortable. But looking at today and the forecast, we have some days of 32 degrees or more coming up. So I put the system back to work and experiment a bit further with it. And one of the most interesting things I've learned is how useful the floor can be as a cooling booster. And at first that might sound a little strange. A concrete floor is a huge thermal mass. It's slow and definitely not agile. And this is absolutely not a quick fix for a house that has already been heated up. But after using the system over the last couple of months, I've started to get a pretty good feeling about how the house responds to it. If I know there's a really hot and sunny day coming, I can start the cooling early and run the system for half a day or throughout the entire day during heat waves. And that's where it really seems to make a difference. Even with temperatures above 30 degrees outside, I've been able to keep the house around 24 degrees inside. And I'm really surprised about today. It's now 35 degrees outside and about 23 inside. Thinking again about this, it almost sounds unbelievable, right? But yeah, those are the measures now. And yes, this is combined with the ceiling fan to provide enough airflow for the floor. And even more important, if I can learn to predict how the house responds to the weather, I can eventually automate that as well. But let's not go down that rabbit hole today. There are still a few things I want to verify. Some of the temperature sensors still need more checking and alignment, but the flow sensors are now giving me readings that seem quite reasonable to do some basic calculations and give at least some more insight. So let's have a quick look at some of the data. I already showed some graphs and metrics throughout the video, but here I want to go a little bit more into detail about the data that we've gathered. I think one of the most important metrics here is the temperature difference between the supply and return temperature. And this is actually fun to see, because we now see a quite small delta in the temperature of less than 2 degrees. And this is because the buffer is almost empty. So at this moment it is refilling. And we also see that at the power use of the groundwater pump. So it is filling up, and we see that the delta is increasing as well, because the reservoir is filled with fresh cooling water. And we will see that it will increase over time during the video. So this is the graph about the delta, the temperature difference between the inflow and the outflow of the floor water circuit and the actual temperatures. So we see that the delta is around like 5 degrees. And to keep it simple, I'm using like a time frame of only today. And we see that there are some dips, and that is at the moment that the buffer is refilled. If we look at the actual temperature differences, then we see that the water inflow, it's called here, but it's like the return of the floor. So the return is about like 20 degrees, 19 degrees. And the supply towards the floor is around like 14 degrees till like 15 degrees. And it varies, of course. And let's do the same for the flow on both of the circuits. And also here, to make it simple, I chose for a little bit smaller time frame. And as we can see here, the side of the floor has quite a stable flow, because it's a closed circuit, so there's nothing changing there. Why the side of the groundwater flow, the supply of the cooling water, gives that much variety, I don't know exactly, because it varies from like 20 to about the 90 liters an hour that I've set with the PWM controller. So this is definitely something that I need to dive in further, how to get like a stable measure there. Just as a check, let's choose for a really small time frame and see what the measures are then. Then we still see that it goes quite all over the place, but at least we have a little bit a better idea about what it is doing. And I will also just do some simple bucket measure test and then see how that compares with the results from the flow sensor. But at least based on this, we can quite safely say that on the floor circuit we have a flow of about 120 liters an hour, and let's say that on the cooling water supply side we have a flow of like around, let's call it 80 liters an hour. Then we still see that like we have a bedroom of 23 degrees, living room of 24, and an outside temperature of 34. And I think it's interesting to compare a little bit here as well, like not only a snapshot in time, but like over the last day. And this of course triggers again, like if we have a very low temperature over the night, is a perfect moment to ventilate more. So I really want to work further on that by automating my ventilation system to provide more ventilation on those moments when I want to cool the house over the night. But I think those are the most important facts of the data. Like if we look at the morning, when the temperature outside rises to like in the afternoon to the 34, 35 degrees, then the house stays stable at around like 23 degrees till end of the afternoon when it reaches like 24 degrees. So I think that's a really nice outcome of this experiment so far. And I think that's also quite relevant, because you can see that I'm actually sending water in the floor at a pretty low temperature of around 14 degrees. And looking at a lot of the information that I can find online, that's definitely lower than would normally be recommended, mainly because of the risk of condensation on the floor. But while running the system like this over the last few days, I haven't had any issues with condensation at all, simply because the actual surface of the floor never reached the temperature low enough to cause condensation. And besides this, you saw the flow rates. Both the groundwater side and the floor circuits are running around 100 liters an hour, giving us the delta of around 5 degrees that we saw earlier. And as somebody mentioned in the comments on one of the previous videos, a delta of around 5 degrees would be quite normal behavior for the type of heat exchanger that I'm using here. So I guess that also lines up quite well, having roughly the same flow on both sides. The bigger delta of around 7 degrees that I had earlier was probably caused by providing much more cooling water to one side of the heat exchanger, which resulted in that larger temperature difference. And if you have any questions or comments about the data, or if there are specific metrics you'd like to see in more detail, definitely let me know. Over the last months there has been quite a few interesting comments about this. Some of you even started doing your own calculations with the values visible in the graphs, which I really appreciate. So if you have ideas for getting more insight out of the data, or there are other things that you think would be relevant to measure, let me know. I can at least see if I can get those things implemented. So to quickly summarize what we've done. For me, the biggest improvement is the PWM controller. I now have direct control over the groundwater flow, which affects both the amount of water I use and the cooling capacity of the system. And that becomes even more important if we start getting close to condensation on the floor. If I can detect that we are cooling too much, I now have a tool that allows the system to simply reduce the flow. There are several ways I can eventually detect and control that, but I'll keep that high level for now. The second improvement is the smarter buffer control. At this point, I basically press one button, start cooling system, and the rest manages itself. If cooling is disabled, the pump doesn't run and the buffer isn't refilled. If cooling is enabled, the system monitors the flow and refills the buffer whenever necessary. And finally, we looked at some of the data from the last few weeks. Data that will be eventually the foundation for automating the whole system. So I'm sure we will get back to that. And now what's next? There are still a few boring jobs to finish. I want to properly cover the insulated pipes coming out of the wall and clean up the installation on the attic a little bit. And yes, I still need to fix that drain, like really. But the thing I'm most curious about now is playing around with the automatic flow control. For example, could I automatically adjust the groundwater flow to maintain a constant temperature delta across the floor circuit? I don't even know if that's the control strategy I eventually want to use. But that's not really the point yet. I want to understand what I can control and how the system responds, and how all those different variables affect each other. But that's something for later. So that's it for the technical side of the project now. It's actually been a few weeks since I made a proper technical video. And in between I made my 6 months on YouTube video, which I personally really enjoyed, because it gave me a chance to explain a little bit more about why I am doing this and what this channel is all about. And in the meantime, more of you real people have started following these projects, which is really awesome. And what I probably enjoy most are the discussions that come with it. And they're even not just about the technical side anymore. We've somehow ended up discussing all kinds of things. And I really like that, because it means people are actually getting involved, sharing ideas and thinking along with these projects. And that's one of the reasons I started doing this in the first place. I have no idea where all of this is going, but I really appreciate having you all on board while I figure it out. Whether that's seeing how far we can push this groundwater cooling project, hacking the electronics of my hot tub to make it as smart and cheap to run as possible, or one of the many other projects I have already in mind. And knowing myself, those projects might go even further off track than they already do. But let's try to finish some of my open projects first. I'm also thinking about making a small video about some of the projects that I have in mind, just to hear what you think before I start building them, and maybe get some ideas about what I should add to them. But that's for another day. let's call it a day for now. This video became already much longer than I had in mind at the start. So there we go. Thanks for watching. Again, this was Forest Guy Builds. I'm John and I hope to see you in one of my other builds.